the Dakota Territory in McHenry County in the winter of 1882-83, was in the middle of what the settlers who survived it would later call the hard winter. The succession of blizzard events beginning in October of 1882 and extending through March of 1883 that buried the prairie under snow accumulations that exceeded 4 feet on the open land and 12 to 15 feet in the coulees and low spots where the northwest wind deposited its drifts. McHenry County had been settled for less than 4 years when the hard winter arrived. The Northern Pacific Railroad had reached the region in 1882. Bringing the homesteading families who had filed their claims in the summer and had built their first-year dugouts and shanties, and were now facing a winter that none of them had experienced, and that the few established settlers who had been there longer could not adequately describe to people who had never seen the Dakota Prairie in a serious blizzard. The blizzard of January 12, 1883, arrived as one of the most severe single events of the hard winter. The temperature dropped from 15 degrees above zero to -28 in 6 hours. The northwest wind reached 45 miles per hour, and the snow that had fallen in the previous week and consolidated on the prairie surface was picked up by the wind and added to the falling snow from the new storm, producing a complete whiteout in which the visibility on the open prairie was zero at distances greater than 4 feet. The blizzard lasted 63 hours, from the afternoon of January 12th through the evening of January 14th, and when it was over, the drifts on the northwest faces of every structure in McHenry County had grown by 4 to 8 feet, and the temperature was -31. Anna Bergstrom had been on her claim in McHenry County since June of 1882. Having arrived from Minnesota with her husband Lars and their son Eric, who was 14, Lars had gone back to Minnesota in November of 1882 to collect tools and supplies that they had not been able to bring on the initial claim trip, and had been unable to return to the Dakota claim before the first blizzard of the hard winter sealed the roads in late November. He was in Minnesota. Anna was on the claim with Eric. The claim had a 12 by 14-foot sod shanty and a separate sod barn, approximately 20 feet from the shanty's north side, and the firewood supply that Lars had cut and stacked before he left, approximately 3 cords of cottonwood, stacked in a pile beside the barn's south face. The firewood supply was the problem that Anna identified on January 9th, 3 days before the blizzard arrived. The barometric pressure had been dropping for 2 days, and the sky had the quality that the Minnesota winters had taught her to associate with serious incoming weather. A high, thin haze that gave the sun a yellowish cast and reduced the horizon definition. She had been watching the woodpile, which was unprotected, stacked beside the barn's south face in the standard open-air method, and she had been watching the drift that was building against the pile from the northwest. The previous week's snow had already deposited a 3-foot drift against the pile's northwest face, and with the incoming storm she calculated that the drift would rise to 8 or 10 feet above the pile's top by the time the blizzard was finished, packing the individual pieces of cottonwood into a solid mass of snow-bonded wood that would require sustained effort to penetrate each time she needed fuel. At -30 and -40 wind chills, with a firewood pile that took 30 minutes of effort to access each time, the wood pile would become effectively inaccessible for any sustained period. She could not spend 30 minutes outside in the accessible wood in that cold, and the shanty would begin losing temperature within hours of the stove running down. She needed to access the wood from inside, or from a covered path that protected her from the wind and allowed her to reach the wood pile in the time and at the temperature that safety permitted. She had 3 days. The solution was the snow itself. The drift that the northwest wind was already building against the barn's northwest corner and the woodpile was the raw material for a tunnel that would connect the shanty to the barn and the woodpile without requiring exposure to the open weather. She had seen snow tunnels described in Eric's school reader, a passage about Norwegian mountain farms where the inhabitants built snow tunnels between buildings for winter passage, and she had seen Lars dig into a large drift once in Minnesota to retrieve a tool that had been covered. The tunnel was not a novel idea. What was novel was her specific application, not a passage between existing buildings, but a covered trench from the shanty to the woodpile that would allow her to retrieve firewood without exposure. She and Eric began on January 9th. The drift that had accumulated against the barn's northwest corner was already 4 feet high and 8 feet long, and the northwest wind was continuing to add to it. She had Eric pack the drift surface with a flat board, consolidating the wind-deposited snow into a harder mass that would hold its shape when excavated. From below, while she excavated the trench from the shanty door toward the barn, the trench was 18 inches wide and 3 feet deep, cut through the accumulated surface snow from the shanty door approximately 20 feet to the barn's south wall, then along the barn's south wall to the woodpile position. The total trench length was approximately 35 feet. The excavation from the shanty door to the barn took most of January 9th and the morning of January 10th. The snow was consolidated enough from the previous week's accumulation to require the spade rather than simple scooping, and the 14-foot width of the shanty's shadow had produced a slightly different snow texture than the open drift, harder in some sections, looser in others. She shoveled the excavated snow onto the trench's sides, building the trench walls up with the spoiled material and packing them with the board. By the evening of January 10th, the trench from the shanty to the barn was complete, and the trench walls stood approximately 3 feet above the shanty's ground level, a total of 6 feet of depth from the top of the trench walls to the trench floor, creating a passage that was 6 feet below the wind-driven snow surface that a blizzard would produce. The covering the trench needed a roof. She had 2 tools for this: the surface snow itself, which could be packed into a consolidated arch over the trench opening, and the boards from the surplus lumber that Lars had left in the barn. She used both. From the barn's lumber supply, she cut 4 boards to the 18-inch span width of the trench and placed them across the trench at 5-foot intervals, resting on the trench wall edges. The boards were the structural support. The snow was the insulation. She packed the wind-consolidated drift snow over the boards, building a snow arch approximately 2 feet thick over each board section. Between the board sections where the trench was spanned only by the packed snow arch, she cut blocks from the consolidated drift and laid them like primitive masonry across the trench opening, each block bridging the 18-inch gap and overlapping the adjacent blocks by 3 inches on each side. By the evening of January 11th, the day before the blizzard arrived, the trench was fully covered for its entire 35-foot length. She crawled through it as a test, 18 inches wide, 3 feet high at the lowest point under the board sections, slightly higher in the snowblock sections where the arch provided more clearance, dark and closed, with the smell of the snow and the barn at the far end. At the barn end, she had opened the trench into the woodpile area by excavating a small working space, approximately 4 feet square, where the stacked cottonwood logs were accessible from below. She had dug down to the bottom course of the woodpile and could reach individual pieces without the drift above being any obstacle at all. The working space at the woodpile end was the critical element. It gave her access to the full woodpile from below the drift level, where the drift had no effect on individual piece accessibility. She loaded the shanty's interior with as much wood as she could carry in the remaining hours of January 11th. 12 armloads through the tunnel, enough for approximately 2 days at a moderate stove rate. She noted in the household diary that Lars had asked her to keep. January 11th, 1883. Tunnel complete from shanty to woodpile, 35 feet covered, wood loaded for 2 days. Blizzard expected tomorrow. We will not need to go outside for the duration. We will not need to go outside for the duration. The tunnel was not a thermal improvement to the shanty. It did not warm the building or reduce the fuel consumption. It was an access system, a method of reaching the fuel supply without exposure to the conditions that would make the fuel supply inaccessible. The blizzard did not improve the wood's quality or reduce the amount needed. It protected the pathway to the wood from the conditions that would otherwise eliminate the pathway. The blizzard arrived on the afternoon of January 12th. The temperature dropped 43 degrees in 6 hours. The wind reached 45 miles per hour. The snow covered the tunnel's surface, adding another 4 to 6 feet of drift on top of the covered trench. None of this mattered to the tunnel. It was below the drift, carved into the already consolidated base, snow. Its walls and roof, made of material that was only becoming more consolidated and more robust as the new blizzards, snow compacted the existing drift above it. The tunnel became, as the blizzard deposited more snow above it, increasingly well insulated. The new snow was additional insulation on the roof, and the temperature inside the tunnel during the worst of the blizzard was approximately 22 to 25 degrees Fahrenheit, far below the shanty's temperature, but far above the -20-8 degree outdoor air that the wind was driving at 45 miles per hour across the open prairie above. She made 4 wood retrieval trips through the tunnel during the 63-hour blizzard, once on the evening of January 12th, once on the morning of January 13th, once on the afternoon of January 14th, and once on the evening of January 14th when the blizzard was ending. Each trip took approximately 5 minutes. She opened the shanty's exterior door into the tunnel, crawled the 35 feet to the woodpile working space, retrieved 6 to 8 pieces of cottonwood, and returned. 5 minutes in 22-degree air versus 30 minutes in -20-8-degree air with 40-5 mile per hour wind. The difference between the two was not merely comfort, but survival. 30 minutes of exposure to -20-8-degree air at 45 mile/hour wind chill produced a wind chill equivalent of approximately -75 to 80 degrees, which was lethal exposure time for an unprotected person without exceptionally heavy clothing. She could not safely make the open-air trip to the woodpile in those conditions. She could safely make the tunnel trip. She noted each trip in the diary. January 12th Eve. Tunnel trip 1. 6 pieces, stove loaded. January 13th morning. Tunnel trip 2. 8 pieces. Temperature outside EST, -31. Wind very strong. Tunnel interior EST, 22 degrees, 5 minutes each trip. January 14th, afternoon. Tunnel trip 3. Blizzard continuing. January 14th evening. Tunnel trip 4. Blizzard ending. Wind dropping. Will assess tunnel condition tomorrow. January 15th. She crawled through the tunnel and found it intact. The blizzard's additional snow had compressed the tunnel roof further, reducing the clearance in the snowblock sections by approximately 3 inches. But the tunnel was fully passable. She widened the compressed sections with the spade from inside, restoring the full clearance. She loaded the shanty with 3 days' worth of wood and emerged from the barn end of the tunnel into the post-blizzard outside. The first time she had been in the open air since January 11th. The woodpile was completely buried. The drift above the woodpile working space was approximately 9 feet deep, but the woodpile itself was intact and fully accessible from below through the tunnel working space. She had lost no wood. Every log that Lars had cut before he left was available. She had saved every log. The McHenry County Historical Society in Towner, North Dakota, has the Anna Bergstrom Household Diary, 1 volume from June 1882 through September 1883, donated by her granddaughter, Selma Bergstrom Haugen, in 1944. The January 9th through 15th entries document the tunnel construction and the 4 blizzard wood retrieval trips. The key phrase, "We will not need to go outside for the duration," is in the January 11th entry. The record is in Towner. It is still there. The specific engineering of the snow tunnel, which Anna had not described in physical terms in the diary, but had described with the precision of someone who had thought through each element before executing it, can be stated with enough clarity to explain why the tunnel held through a blizzard that deposited an additional 4 to 6 feet of snow above it. The tunnel's structural principle was compression arch action. When snow is packed into an arch over an opening, the arch distributes the load from the snow above it to the arch's supports at the tunnel walls, and the snow arch itself is held in compression, the same structural principle as a stone arch, where the arch material is strong in compression, and the arch geometry converts the PCO applied load into compressive force rather than bending force. Snow packed to a density of 30 to 40 pounds per cubic foot. The consolidation that the previous week's wind-driven accumulation had produced has compressive strength sufficient to span an 18-inch gap in arch form. Without failing under the additional snow load of a blizzard, the arch does not break. It consolidates further as the load above it increases. The board sections at 5-foot intervals were insurance, not primary structure. If an arch section had failed during the blizzard, the board would have caught the fallen snow and maintained the passage below. The boards were the redundancy that Anna had added because she was not certain of the snow arch's performance under the worst-case blizzard load. The boards cost her the time to cut them to width and position them. They provided the margin against structural failure that the snow arch alone might not have provided in the most extreme conditions. The trench depth of 6 feet total from the top of the trench walls to the trench floor was not arbitrary. It was calculated from Anna's estimate of the maximum drift height that the incoming blizzard would produce above the existing snow surface. The previous week's blizzard had produced a 4-foot drift against the barn's northwest corner. The incoming storm's forecasted severity suggested an additional 4 to 6 feet. 6 feet of total trench depth meant that the tunnel would be 2 to 4 feet below the maximum drift surface, even at the worst drift accumulation. Below the drift surface, the wind had no access to the tunnel interior. The wind moved above the drift surface, carrying away the heat and creating the lethal wind chill above. The tunnel interior was below the drift surface and therefore outside the wind's access, at the quiescent temperature of the consolidated snow mass, rather than the wind-driven temperature of the open air. The 22 to 25 degree temperature that Anna estimated inside the tunnel during the blizzard reflected this. The consolidated snow surrounding the tunnel had a temperature determined by its own mass and the outdoor air temperature, not by the wind. Snow is an excellent insulator. Its thermal conductivity of approximately 0.1 to 0.3 W per mK for consolidated winter snow is low enough that a 2-foot thickness provides approximately R10 R20 of thermal resistance. The 2 feet of snow above the tunnel roof at the board sections, combined with the several feet of consolidated drift that the blizzard was adding, provided enough thermal resistance to maintain the tunnel interior at 22 to 25 degrees, even when the outdoor wind-driven temperature was approaching -75 wind chill. The tunnel was not warm, but 22 degrees was 57 degrees warmer than -35, and it was survivable for a 5-minute transit. The specific construction decisions that Anna made during the 3-day preparation period, the trench dimensions, the wall construction from excavated spoil, the alternating board and snow block roof, and the working space at the woodpile end, each addressed a specific operational requirement that the tunnel needed to meet. The trench width of 18 inches, wide enough for a person to crawl through while carrying firewood pieces, narrow enough to be spanned by the available board stock and by the snow blocks she could cut from the consolidated drift. A wider trench would have required larger spanning elements and more material. A narrower trench would have made the passage difficult with an armload of cottonwood. 18 inches was the operational minimum for the specific task. The trench depth of 3 feet below the existing snow surface, Anna dug from the original snow surface downward, placing the tunnel floor at 3 feet below the surface where she began, combined with the 2 to 3 feet of trench wall that she built up above the original surface level from the excavated spoil. The total passage depth from tunnel floor to the top of the trench walls was approximately 6 feet, enough to bring the passage below the maximum expected drift surface of the incoming blizzard. The alternating board and snow block roof was the creative element, boards where she had them, snow blocks where she did not. The boards spanned the trench at the structural supports. The snow blocks filled the sections between the boards. The snow blocks were cut from the consolidated drift material of the barn's northwest corner, the hardest, most compressed snow available, which had been under wind pressure for a week. She cut the blocks approximately 12 inches long, 6 inches wide, and 6 inches thick, dimensions that allowed them to bridge the 18-inch trench span while resting on the trench wall edges with 3 inches of bearing on each side. The blocks were laid with their long dimension perpendicular to the trench length, bridging from one trench wall to the other. She had noted the block cutting process in the diary entry of January 10th, 1883, cutting snow blocks from the northwest corner drift for the roof. Hard snow like soft brick, it cuts cleanly with the spade, laying them across the trench in 2 offset courses, same as brick. The offset course is the second course of blocks positioned, so each block's joints were above the midpoints of the blocks below, distributed the load across the joints rather than concentrating it at a single joint line. It was the same structural principle as brick coursework. The strength comes from distributing the load path through the mass of the blocks rather than along the joint lines. She had not stated this principle. She had applied it intuitively from observation of brick and stone construction. The working space at the woodpile end. This was the element that made the tunnel system function for its intended purpose. Without the working space, the tunnel would have connected the shanty to the barn, but not to the woodpile, which was outside the barn's south face and would have been under 8 to 10 feet of drift. By excavating a 4 by 4 foot working space at the end of the tunnel, below the drift level, with the bottom of the working space at the same level as the bottom course of the woodpile, Anna created an access chamber that allowed her to reach the wood from below the drift, from a position where the drift exerted no vertical load on the individual pieces and where she could separate pieces and carry them back through the tunnel, without the weight of 9 feet of drift to resist. The working space was essentially a pit excavated below the drift level at the woodpile's base, large enough for her to turn around in and pass wood pieces back into the tunnel. The drift above the working space rested on the drift on all four sides. The working space was a void within the drift, not a gap in the surface, and the void was stable because the surrounding, consolidated drift was strong enough in compression to arch over a 4x4 foot span at the drift's full depth without collapsing. She had tested the working space stability by spending 5 minutes in it on January 11th before the blizzard arrived and finding the drift above it solid. No cracking, no settling, no indication of imminent collapse. The 3-day preparation window, which is the specific element that the title had emphasized, was both the constraint and the enabling condition of the tunnel construction. The constraint: if she had had only 1 day, the tunnel would not have been complete before the blizzard arrived. The trench excavation alone required a full day and a half for 2 people working in the consolidated drift conditions of early January. The roof construction required another day. The working space at the woodpile required several hours. 3 days was approximately the minimum time required for the construction. The enabling condition: the 3-day lead time from the weather signs to the blizzard arrival was what had given her the construction window. She had read the weather signs on January 9th, the barometric drop and the sky quality, and had acted immediately. If she had waited for the blizzard to arrive to recognize the problem, the construction would have been impossible. In the blizzard conditions of January 12th through 14th, working in the open at -28 with 45 mph wind to excavate and roof a 35-foot tunnel was not possible. The tunnel had to be built before the blizzard, not during it. She had been watching the weather and the woodpile simultaneously, and the convergence of the 2 observations, serious weather approaching, woodpile exposed and unprotected, had triggered the tunnel construction on the first day. The signs indicated a major incoming event. The Norwegian school reader entry about mountain farm snow tunnels had been in her memory. The approaching blizzard had activated it. The combination of memory and observation and the 3-day window had produced the 35-foot covered tunnel before the blizzard arrived. She noted this connection in the diary. In the January 9th entry, when she decided to begin, January 9th, 1883, sky showing major storm, barometer falling, woodpile will be buried and locked. Remember the Norwegian farms in Eric's reader, snow tunnels between buildings for winter access. This is the same principle we start today. This is the same principle. She had taken the principle from a school reader description of Norwegian mountain farm practice and applied it to the specific problem of the Dakota Territory woodpile access in a blizzard. The principle had been in the reader for a reason. The Norwegian mountain farmers had developed the snow tunnel as a standard winter practice for exactly the access problem that Anna was facing. The school reader had preserved the knowledge. Anna had applied it. The blizzard had confirmed it. The McHenry County Historical Society in Towner, North Dakota. 1 volume, June 1882 through September 1883. Donated in 1944 by Selma Bergstrom Haugen. The January 9th through 15 entries. The weather observation, the tunnel decision, the construction sequence, the 4 blizzard trips, the post-blizzard inspection, the wood pile intact. The key phrase: we will not need to go outside for the duration. The record is in Towner. The woodpile was saved. Every log was there when the blizzard ended. The tunnel had held the broader context of the hard winter of 1882–83 in Dakota Territory, which placed the Bergstrom Farms tunnel construction within one of the most severe winter events in the recorded history of the Northern Great Plains. Is worth establishing because it explains both the severity of the problem that the tunnel addressed and the inadequacy of any response that relied on outdoor exposure. The hard winter of 1882–83 was not a single event but a succession of blizzard events. Beginning in October of 1882 and extending through March of 1883, that together deposited snow, accumulations unprecedented in the short recorded weather history of the Dakota Territory. The October and November blizzards had established the base snowpack. The January events, including the January 12–14 blizzard that tested Anna's tunnel, added to this base and produced the maximum accumulation depths of the season. By mid-January 1883, the prairie in McHenry County had a base snowpack of approximately 2 to 3 feet in the open, with drifts of 8 to 15 feet in the coulees and on the lee sides of any structure or terrain feature. The specific danger of the January 12th blizzard was not Primarily the snow accumulation, the base was already established, but the temperature and wind combination, -28°F with 45-mile-per-hour wind, produced a wind chill that had no formal measurement system in 1883, but that corresponded, by modern wind chill index calculation, to approximately -75 to 80°F. At this effective temperature, exposed human skin freezes in approximately 2 to 4 minutes, and unprotected hands and feet can be disabled in 10 to 15 minutes. A trip to the woodpile of 30 minutes, the time that would have been required to penetrate the drift above the pile without the tunnel, was lethal exposure time. The hard winter's body count was significant and specific. The Dakota Territory casualties of the 1882-83 winter were primarily people who had been caught in the open during blizzard events, or people who had ventured outside their shelters for what they thought would be brief errands and had been unable to return. The specific hazard was not the cold itself. The shelters, even the poorly insulated first-year sod shanties, were survivable in sustained cold with adequate fuel, but the necessity of going outside for fuel when the fuel supply was buried by the drift. Anna's tunnel had eliminated this hazard by making the fuel accessible without outdoor exposure. She had understood this explicitly. The January 9th diary entry had not just noted the weather signs. It had calculated the woodpile access problem with the precision of someone who had already been through one. Hard winter blizzard, January 9th, 1883. If the big storm comes, the woodpile will be under 8 or 10 feet of drift. Without a covered access, I would need to dig into the drift for 30 minutes each time in the worst cold. At these temperatures, 30 minutes outside is not safe. The tunnel changes this to 5 minutes inside the snow. 5 minutes is safe, 30 is not. The tunnel is the only reasonable solution. The tunnel is the only reasonable solution. She had written this on January 9th, 4 days before the blizzard arrived, and the blizzard had confirmed her analysis. No neighbor who attempted open air wood retrieval during the January 12th to 14th event without previous preparation had been able to do so safely. The Hendersons 2 miles east had not built a tunnel and had spent the worst 36 hours of the blizzard without loading their stove because the woodpile was inaccessible. Their shanty dropped to 26 degrees and stayed there until the blizzard broke. They survived, but the 26-degree period had been dangerous and the subsequent wood retrieval. Breaking into a 9-foot drift with frozen hands in -30-1 degree weather on January 15th had taken more than an hour and produced frost-damaged hands on both members of the household. Anna noted the Henderson situation in the January 16th diary entry. January 16th, 1883. Visited Henderson's. They had no tunnel and could not safely access the wood for the worst 36 hours. Shanty at 26 degrees. Both have frost damage to hands from the January 15th retrieval. I showed them the tunnel. The woman said, 3 days was all it needed. I said, yes, 3 days was all it needed. The tunnel was 35 feet. 3 days was enough. The blizzard got nothing. The comparison between the Bergstrom snow tunnel and the other access management mechanisms in this series, as distinct from the thermal management mechanisms that constitute most of the series, illuminates the specific category of problem that access management addresses. Most of the mechanisms in this series had been about thermal performance, making the space warmer, making the fuel more efficient, making the heat loss slower. The snow tunnel addressed none of these. The shanty's thermal performance was unchanged. The cottonwood's moisture content was unchanged. The stove's efficiency was unchanged. What changed was the accessibility of the fuel, the ability to get the fuel from the pile to the stove without encountering conditions that made the fuel retrieval unsafe. This is a different class of problem from the thermal management that the other mechanisms addressed, and it required a different class of solution. The Dakota Territory blizzard was not primarily a problem of insufficient heat generation. The cottonwood supply was adequate. The stove was functional. The sod shanty had reasonable insulation. The problem was the gap between the fuel and the stove, and the 63-hour blizzard had made that gap lethally dangerous to cross. The tunnel bridged the gap physically, eliminating the dangerous crossing without improving any other element of the system. In the language of system engineering, the tunnel had resolved a bottleneck. The fuel supply was adequate. The conversion system was adequate. But the access between supply and conversion was the system's limiting constraint. The tunnel removed the constraint. Once the constraint was removed, the system performed adequately through the blizzard. Without the constraint being removed, the system would have failed at the bottleneck, the woodpile would have been inaccessible, the stove would have run down, the shanty would have dropped to dangerous temperatures, regardless of the wood supply's adequacy or the stove's efficiency. She had identified the bottleneck on January 9th when she calculated that the incoming blizzard would make the woodpile access the system's critical vulnerability. She had removed the bottleneck with 35 feet of snow tunnel over 3 days of construction. The system performed. The blizzard got nothing. Every log was saved. The McHenry County Historical Society in Towner, North Dakota. 1 volume, June 1882 through September 1883. The January 9th entry. The weather observation. The woodpile calculation. The Norwegian farm connection from Eric's reader. The decision. The January 10th to 11th entries. The construction sequence. The block cutting. The working space. The January 12th to 14th entries. The 4 tunnel trips. The 5-minute transit times. The tunnel interior temperature. The January 15th entry. The post-blizzard inspection. The tunnel intact. The woodpile accessible. Every log saved. The key phrase, we will not need to go outside for the duration. The record is in Towner. The blizzard got nothing. The record has said so since January 1883. It still does. The 9 months of the Anna Bergstrom household diary, from the first entries of June 1882 through the final entries of September 1883, document the complete first year of the McHenry County claim in the specific format that she had promised Lars she would maintain. A daily record of farm events, weather observations, and accounts of significant occurrences. The diary was written for Lars, who was reading each volume when Anna could get them to him through the postal service, and the tone throughout is that of a letter as much as a farm record. She explains her reasoning, describes the conditions she was managing, and notes what she had decided and why in enough detail that Lars could follow the events as she had experienced them. This is why the January 9th through 15 entries are among the most detailed in the volume. She was explaining to Lars, in the entries she would send him when the postal service resumed, what she had done about the woodpile while he was gone, and she needed him to understand both the problem and the solution. The January 9th entry has the weather signs, the calculation of the drift's effect on the woodpile, the reference to the Norwegian farm tunnel from Eric's reader, and the decision to begin construction immediately. The January 10th and 11th entries document the construction day by day. The 4 blizzard trip entries are brief. She was cold and tired when she wrote them, but specific about the temperatures, the trip durations, and the wood amounts retrieved. The January 15th entry, written after she had inspected the tunnel and confirmed the woodpile intact, has the full accounting 35 feet of tunnel, for trips during the blizzard, 5 minutes each, every log saved. Lars read the January entries when they reached him in Minnesota in late February 1883. He sent back a letter that the McHenry County Historical Society also has. As part of the Bergstrom family papers donated alongside the diary, he wrote that he had not understood, reading the diary from the safety of Minnesota, how the hard winter had been in Dakota Territory until he read the January entries. He wrote, "I should have been there." She wrote back, in a February entry, "The tunnel was enough. The tunnel was enough. 3 days before the blizzard, 35 feet of covered passage, 4 5-minute trips through the snow, 63 hours of blizzard above, every log saved. The tunnel was enough." The McHenry County Historical Society has the diary and the Lars letter. The record is in Towner. It is still there. The specific reference in Anna's January 9th diary entry to Eric's school reader and the Norwegian mountain farm snow tunnel that the reader described is the documentation of how the knowledge had traveled from the Norwegian farming tradition to the McHenry County claim in a way that is characteristic of the broader pattern of knowledge transmission in the American frontier period. The Norwegian practice of building snow tunnels between farm buildings during heavy winter snow accumulations was a response to the same access problem that Anna faced in the Dakota Territory. The Norwegian mountain farms, isolated on steep terrain where the winter snow was deep and the storms were severe, needed to access their barns and outbuildings without crossing the open snow surface in conditions that were dangerous. The tunnels they built, typically wider and more permanent than Anna's 35-foot trench, because the Norwegian snow conditions were more predictable and the construction could be planned across full autumn before the snow arrived, connected the farmhouse to the barn and allowed the winter farm work to continue, regardless of surface conditions. The school reader that had brought this knowledge from Norway to Dakota Territory was one of the standard readers used in the Minnesota public schools in the 1870s and early 1880s, which included passages about Norwegian immigrant farming practices as part of their content on the communities from which many Minnesota children came. Eric had been 14 when the family arrived in Dakota Territory. He had been attending school in Minnesota when the reader passage about Norwegian farm tunnels had been part of the curriculum. He had brought the reader with him to the claim, and it was in the shanty when Anna needed it. The school reader was not a technical manual. The passage about Norwegian farm tunnels described the practice in general terms. The tunnel connects the house to the barn, built from snow blocks in an arch. The passage stays at the temperature of the snow rather than the outdoor air, but did not specify dimensions or construction methods beyond the general description. Anna had supplied the dimensions and methods herself, working from the general principle and the specific materials and conditions available on the claim. The 18-inch width, the 6-foot total depth, the alternating board and snowblock roof, the working space at the woodpile. These were her engineering judgments, applied to a general principle that the school reader had preserved. This is the specific value of the school reader in the transmission chain. It had preserved the principle in a form that was accessible to a 14-year-old Minnesota schoolboy and therefore to his mother in Dakota Territory 3 years later. The Norwegian mountain farmers had developed the practice over generations of cold-weather farming. The school reader had summarized it in a few paragraphs. Eric had learned those paragraphs as part of his education. Anna had read the reader and remembered the principle when the January 9th weather signs had activated it. The chain from Norwegian practice to Dakota Territory application had run through a school curriculum, which was the specific transmission mechanism that had preserved the knowledge for this use. She had noted this in the diary. The school reader had the Norwegian farms. The knowledge was already here. I applied it to the woodpile. The knowledge was already here, in Eric's reader, in the shanty, 3 days before the blizzard arrived, at exactly the moment she needed it. The transmission had worked. The principle had been preserved. The application had been successful. The post-blizzard period, from January 15th through the end of the winter, is documented in the diary, with entries that show the tunnel continuing to function as the primary woodpile access route for the remaining weeks of the hard winter's worst events. Anna did not collapse the tunnel after the January 12th to 14th blizzard. The tunnel was sound. The drift above it was consolidated and stable, and the woodpile continued to be accessible through the working space at the tunnel's end. She used the tunnel for wood retrieval throughout January and into February. When the second major hard winter blizzard event of 1883 arrived on February 14th and lasted 44 hours, for this second event, the tunnel required no preparation. It was already in place. She noted, February 14th, 1883, second major blizzard, tunnel intact from January, no preparation needed, wood accessible throughout, shanty maintained at 58 degrees during the event. This is what the tunnel is for. This is what the tunnel is for. The January construction had been a response to a 3-day warning. The February event had no preparation requirement because the January construction had been durable enough to serve the entire remaining winter. The tunnel had not been a one-time emergency structure. It had become, as the hard winter continued, the standard access route to the woodpile for every storm event through March 1883. Lars returned to the Dakota claim in April 1883 when the road conditions permitted. He found the shanty in good condition, the woodpile approximately 2/3 consumed, the usual rate for a Dakota Territory winter, and the tunnel still intact in the Bython consolidated drift. He wrote in the diary, in the first entry after his return, April 1883, arrived home. Tunnel still visible, mostly intact. Anna showed me the working space at the woodpile end. All the wood is there that was not burned. The tunnel was everything. The tunnel was everything. He had written this as an assessment of what the tunnel had been in practical terms during the hard winter, everything that had made the winter manageable in his absence. Anna had written, the tunnel was enough. His assessment was more expansive. The tunnel was everything. Both were correct. The tunnel was enough. It had been what the 3 days of preparation had made possible, and it had performed exactly as the construction required. The tunnel was everything. Without it, the winter on the claim without Lars would have been untenable at the worst moments. The McHenry County Historical Society in Towner, North Dakota. 1 volume of the Anna Bergstrom Household Diary, June 1882 through September 1883, in English and occasionally Norwegian. The Lars Bergstrom letter from February 1883, donated by Selma Bergstrom Haugen in 1944. The January 9th entry. The construction entries of January 10th and 11th. The 4 blizzard trip entries. The post-blizzard inspection of January 15th. The February 14th second blizzard entry. This is what the tunnel is for. Lars's April return entry. The tunnel was everything. Anna's key phrase from January 11th. We will not need to go outside for the duration. The record is complete. The record is in Towner. The tunnel was enough. It was everything. The blizzard got nothing. Every log was saved. The record says so. It always will. The Anna Bergstrom household diary was addressed to Lars, and this addressee relationship is visible throughout the 9 months of its entries, in a way that distinguishes it from the purely transactional farm ledgers and account books of the other accounts in this series. The other documents, the Ingrid Halvorsen farm notebook, the Elsa Brandt household account book, the Lydia Marsh household journal, were records addressed to the farm and to the historical record. The Bergstrom diary was addressed to Lars A, and the tone shifts accordingly from account to explanation, from record to conversation. This is why the January entries, with their detailed account of the reasoning behind each construction decision, are among the most complete technical accounts in the series. Anna was explaining to Lars what she had decided and why, because Lars had not been there and needed to understand the logic in order to trust the result. The herringbone tile pattern of the Voss drain system had been documented because Hendrik was an engineer who documented engineering. The snowblock courses of Anna's tunnel were documented because she was explaining to her husband why she had offset the courses, which required naming the principle, even if only intuitively, same as brick, same as brick. She had written this in the January 10th entry about the offset snowblock courses, and the phrase was the most compressed statement of a structural principle in any of the accounts in this series. She had not read about arch action or load distribution. She had seen brick walls and understood from observation that the offset courses made the wall stronger by distributing the load across the joints. She applied the same principle to the snow blocks, same as brick. It held. The McHenry County Historical Society has the diary, Towner, North Dakota, the January entries with the reasoning for each construction decision, the 4 blizzard trip accounts, and the key phrase, the Lars letter with his assessment from Minnesota, the April return entry, the tunnel was everything. The record is complete. The snow block courses were offset, same as brick. The tunnel held. The blizzard got nothing. Every log was saved. 3 days before the blizzard, the tunnel was built. The record is in Towner. It is still there. The tunnel was enough. It always was.